Okay, so the reason that there's issues with this is because we use a lot of work with variables. Now, I personally don't care for algebra tiles. So if there's anybody that's used them, has anybody used algebra tiles before? Did some last year? Okay, if you like them and you need them, then that can be arranged for you, but I personally don't use them. Okay, and I won't ask questions, I won't ask you to do the questions in the book unless you really want to do them, that's fine. Okay, so I'm going to review what I think you should know from last year. And we'll go through that first, and then we'll introduce some new material. Okay, so I want to expand this out so that it's no longer, I no longer have brackets. What is it going to look like when I expand it out? Go ahead.
3x plus 7? No, plus 12.
3x add 12. This is what we call the distributive property. We multiply the value in front of the brackets through the brackets. Okay, so I have 4x by x plus 2. Or 4x squared plus x squared. No, 4x squared, you got it right. Plus 8x. Alright, so already, how many of us wouldn't know that? Be honest.
Wouldn't know that?
Or wouldn't know that?
Oh, I have no idea.
Okay, so that's what I'm saying. There are parts of this. Okay, so let's review then again. We did that whole section 4 was on radicals. What do I do when I have, what's x times x? X squared, that's pretty straightforward, right? Well, I have x squared and I times it by x cubed. What do I have? X to the 5th. I add my exponents together, right? Okay, so again, we've done a lot of that already. So then when I take 4x and I times it by x plus 2, what I have is 4x times x, add 4x times 2. Okay? 4x times x. Well, 4 doesn't change. What's x times x? X squared. Add, the x stays the same. What's 4 times 2? 8x. So I have 4x squared plus 8x. Multiply it through the brackets. Okay? Questions about this? Alright, let's try another one then. Okay? Amping it up a little bit here. Write down on a piece of paper. Just write down what you think the solution should be. Okay? 2x squared times by x. What's x times x squared? X cubed. The 2, I can't multiply it by anything there. Here, I've got 3 times 2x squared. What's 3 times 2? 6. And x squared stays the same. Okay? How many of us didn't get that one right? Put your hands. Okay, still a few of us, yeah? That's fine. Alright, let's try. Okay, go ahead. That's just an X for the written one. do we get? Same thing. Two x times x squared. X squared times x is x cubed times 2, so it's 2x cubed, right? 2x times 3x, 6x squared. End up with the same thing. Okay, how many of us got that one wrong? Got it wrong. Still a couple, all right. What part are you getting wrong here?
I don't even know what's going on.
What do you mean you don't know what's going on?
That's what I mean.
I'm just gonna.
Go ahead. You wanna go back?
Let me go back. I just doing the x's wrong. I'm doing x fine. Because I did 2x cubed, but then I didn't do a b squared. I just got x wrong.
Okay,
You gotta imagine there's a one.
I'm gonna do this again. You don't have to do this. So go back to here. Go on. I haven't, well, I don't even want that. Let's keep it simple. I have a value in front of the brackets. What do I have to do? I have to distribute it through the brackets and multiply it by everything in the brackets.
Mhm.
Yeah?
Yeah.
What's 3 times x?
3x?
What is it?
3x? No.
It's 3x. What's 3 times 3?
9.
That's all there is to it.
Well, that makes more sense.
Yeah.
What did I start on today? What was the first question I started on?
I've never seen that.
Okay, so now you're back to this point here now.
Yeah, I'm good.
So 2x times x squared,
Yeah, I'm good.
2x times 3x. Brooklyn, you follow that?
Yeah. Probably.
What part don't you?
Also, just the timing part, or like if I add the times, so that like plus signs mess it up.
Okay, well, what it means is this, Brooklyn. I take 2x and I times it by x squared, and I take 2x and I times it by 3x.
Mr. Sinclair, call 15,000, please, Mr. Sinclair.
So I have 2x times x squared, so this times this, and this times that. This times this times that. So I distribute it through. You okay?
Oh, yeah.
Okay. Now we have to know this part because I cannot move on until we do. So let's try one more here. Okay. You got it?
4x cubed plus 8x squared.
Say x squared. Okay, good. All right. 4x squared times x. X squared times x is x cubed, right? 4x squared times 2. 4 times 2 is 8. So that's 8x squared. Follow that?
Mhm.
You okay? Because I gotta take it to the next level, so you gotta know that.
Yeah.
Sure, you okay?
Yeah.
All right. Okay, now, what we are doing is we're setting a base for something we do piles of when it comes to grade 11 and 12 applied degree calculus. So we've got to set the groundwork right now. It isn't something you haven't already done, but it's something that we need to know how to do. So I'm going to show you using the same method that I just used, how to multiply a binomial by a binomial. And then I'm going to show you a simpler method to do it after. So don't necessarily write it down, just follow. Ask questions if you're not understanding, and then I'm going to show you a simpler way of doing this. Okay, so what our intended goal is we have to be able to do this in second nature, which means I want to be able to do this within seconds. So don't write anything down right now. Okay, I'm going to show you what we just did and how we approach it the same way. So if you like that method better, by all means. And then I'm going to show you a method that I prefer because it's easier for me. But both methods work just fine. So the distributive property says this. I take x and I times it through those brackets. And I take 2 and times it through that brackets. So what it means is this, I take x and I times it by x plus 3, and I take 2 times it by x plus 3. So x times that bracket and 2 times that bracket. Okay, so far? Any questions? Just leave pens down, pens down, pens down. I don't want you to write this out yet. Okay, I just want you to follow. Okay, so now I take it through the brackets. Take that x through the brackets. What do I get?
X squared plus 3x.
Plus 3x. That's right. Take that 2 through the brackets. What do I get?
2x plus 3x.
2x plus 6. Okay, so far? So x through the brackets, x times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. Okay, so far? Rowan, you good?
Mm-hmm.
You okay? All right. Now what I do is I add my like terms together. So I have x squared. There's no other x squareds. I have 3x and 2x. What does that give me? 5x. And then I add 6.
That was weird.
What's up?
Did something dumb.
Okay? We okay?
Yeah.
All right, I'm going to do another one using the same method. I'm going to amp it up a little bit and add a subtract sign for right now. Okay, so I take whatever's in the front bracket and I multiply it by the second bracket. So I go x times x add 1. Then I take minus 3 times x add 1. So whatever's in the front bracket, I multiply it by the second bracket. Okay, so far? Anybody not follow? X times x is? X times 1 is? 1x. Minus 3 times x is?
Minus 3x.
Minus 3x. Minus 3 times 1 is?
Minus 3.
You're multiplying, Aaron.
Minus 3.
Minus 3. Okay? Any questions? Brooklyn?
I'm great.
You sure? Come on.
Mm-hmm.
You follow what we're doing? Positive?
Yeah.
If you don't, I can explain it again.
No, I got it.
Okay? Alright? I don't want to lose anybody at this point because it just gets more and more right away here. X squared. I have 1x subtract 3x. What is that?
Minus
Minus 2x. Subtract 3. So x minus 3 times x plus 1 is equal to x squared minus 2x subtract 3. Alright? It's called the distributive property. And all I'm doing is taking everything in the first bracket and times it by the second bracket. Okay, now this method, I said I don't use this method. I do use this method when I have a binomial by a trinomial. Well, what is that? A binomial is 2 terms. A trinomial has 3 terms. So, yeah. No, each bracket, no.
It could have many kinds of numbers.
Yeah.
X is 1, just numbers 1, Y is 1, W is 1.
Yeah, so it's x plus 2, because it's separated by an add, that means it's a binomial.
Oh.
This one's a trinomial because it's got 2 subtract signs in it. Okay? So for right now, this is the method I would use. Now, the question they give you, they fire a fastball right at you off the start here. So I'm going to show it to you, and then I want to go back to our binomials. So I have 2a plus 4, a squared, plus 5a, add 7. Okay, so I have a binomial times a trinomial. So I'm going to set this up. Again, leave your pencils down, please, because if you're writing it down, you're not actually following, you're just writing, you're not. And I understand you need, I'll leave it there. I'll bring it up, you can write it down. Okay, so now, take each term in the first bracket and multiply it by everything in the second bracket. So it looks like this, 2a times all of that. And then I have 4 times all of that. So my second bracket doesn't change. My first bracket, I split it up. We okay so far? All right. What is 2a times a squared?
2a cubed.
It's 2a cubed. 2a times 5a?
10a squared.
Oh. Yeah. Okay. Okay, thanks. Austin, you gotta go, Mr. Sinclair. 2a cubed, 2a times 5a, I missed that, what was it? 10a squared. 2a times 7? 14a.
Good try. That was a good one.
4 times a squared.
4a squared.
4a squared.
Got it in paper.
4 times 5a. 4 times 7.
28.
Okay, so I've now multiplied it all the way through here. Now I want to collect the like terms. So I have a 2a cubed. Are there any other a cubes?
Nope.
No, so there's just a 2a cubed. All right. 10a squared, 4a squared. What does that make?
14a.
14a squared. 14a and 20a.
34.
And 28. So the one thing that you're going to notice is that this goes in descending order of the exponents. Cubed, squared, power of 1, power of 0. Okay? It goes in descending order of the exponents when I actually finalize my answer. Okay? And I simply collect the like terms.
And if it doesn't, if you don't put it in that order, it's wrong.
It's not wrong, no. It's not proper, that's right.
Isn't 14A supposed to be like a 7 to like a 4?
Say that again?
10A squared plus 4A squared, isn't that supposed to be 14A the power of 4?
No, you don't change the exponents unless you multiply. Right? You don't change the exponents unless you multiply them. You understand what I'm saying? If you add a squared with a squared, you get 2a squared. If you multiply a squared by a squared, you get e to the 4th. So the only time you can change the exponents is up here when I'm multiplying. After that, they have to stay the same. Okay? And my analogy for that is this. I have 10 apples. I'm adding 4 more apples. I get 14 apples. I don't get 14 bananas. Okay? I don't change it. Okay. We okay so far? So this is your first method in which might be easier for you to multiply. If you're doing more than a binomial by a binomial, I suggest using this method. There isn't, let me do this again. Sorry, but I will show you one more method. And I don't like, I'm throwing it all out there on day one, but what you'll find is I'm going to do my 2 methods that I like the best more often than not. But if you like it, you like this type of thing, then you can do it. I'm going to show you something else right now. How would you do this? If I asked you to do it, pen and paper, how would you do it?
14 times 3.
Would you say that again? Yes, that's what I was looking for, Rowan. I would stack it.
Oh, yes.
I would stack it. Okay, so I would go 14 by 23, just like that, right? 3 times 4 is 12. Carry the 1. 3 times 1 makes 42, right?
0.
Okay, so I put a 0 or an X there. 2 times 4 is 8. 2 times 1 is 2. Then I add them. Do you agree?
Yes.
2, 2, 3. Right? Carry the 1 on there. We all remember this?
Yes.
Okay. Pretty easy, right? I work right to left. Okay. I add them at the end. I can use this same technique for doing that up there too. And so let me show you that. Okay. I'm going to put a squared plus 5a add 7 on top and 2a plus 4 on the bottom like this. Okay, so I stacked it. Notice I wrote the trinomial on top and the binomial on the bottom. It doesn't matter, but for me it's easier. Okay, I write my larger numbers on top almost always when I do this. This helps. Okay? Alright, so now what I'm going to do, on the question I just did, I worked right to left. Now with polynomials, I'm going to work left to right. So what I'm going to do right now is I'm going to take 2a times a squared. What do I get? 2a cubed. 2a times 5a. 10a squared. 2a times 7. Okay? Now I'm going to times everything by 4. So it's the same thing that I did up there, isn't it? Yeah. Just the different visual. Looks different. So what's 4 times a squared? 4a squared. So I'm going to put it below the 4a squared then. What's 4 times 5a? 20a. And 4 times 7? 28.
Why did you move everything over?
I lined up my a squareds with my a squareds and my a's with my a's. So what am I left with? 2a cubed plus 14a squared plus 34a plus 28. It looks a lot simpler and neater if I line them up like that, doesn't it? Yeah. That's the method I prefer. Okay, now I also understand that if you consistently do the same method, it makes it easier for you too. But I'm okay with whatever works best for you in this situation. All right, so if you want to stack it and do it that way, by all means, that's the way I would do it. If you want to distribute by taking this times the second bracket and that times the second bracket, then by all means, whatever's easiest for you. We following so far? Are there any questions about either one of the two methods? So these two methods are when you have a trinomial and a binomial, or two trinomials, whatever it may be. Are there any questions? Okay. Looks easy when I do it up here. Nice, neat, clean. And then when you go to do it, it turns messy real quick. Okay? Okay. So I said that there is a second method, one in which I would prefer. One I prefer for the binomial method. A binomial by a binomial. X plus 3 times x plus 4. Actually, I'll move this down so above it. All right. My preferred method for doing this is what we call FOIL. You guys heard of FOIL before?
No.
No? Nobody's heard of FOIL before?
Actually, I know this sounds familiar.
Danielle, you have? Okay, so here's how FOIL works. This actually, I find, is the slickest, easiest way to multiply a binomial by a binomial. And that's this. F stands for first. So I'm going to multiply the first in each bracket. So what's the first in each bracket? X times x. So the F part is the first, that's x times x. I'm going to write this out in a long way, and then I'll show you how I quickly do this because it's easier. Hello? Okay. Aaron, you're going upstairs. Please to the office. Okay. Outside. So now, pay attention here, because this is the one that confuses. The outside, if you look at this as two brackets, I'm looking at the ones on the outside of the bracket. So that's this and this. That's outside. Okay? So that's x times 4. Okay? Inside.
You take my library card, I'll see.
Yeah.
Can I have it?
Did I not give it to you?
No.
I don't know if I have it, Don. I thought I did. I'll look for it after. If I get it to you at break, I can. But I don't know. I don't see it here. Okay. So the inside now. That's the next part. Inside. So that if the two on the outside, so what are the two on the inside then?
3x.
3 and x. X, 3, and x, right? And then the last one is what that means. Last is the last in each bracket. So what's the last in each bracket here? 3 and 4. This is called FOIL. First, outside, inside, last. This is the preferred method. This is the method that is the easiest, simplest way of doing a binomial by a binomial. You'll see it. Once we get going, you'll understand it's way easy. All right? So, x times x, x squared. X times 4, 4x. 3 times x, 3x. And 3 times 4, 12. Put your like terms together.
Wow, what did you
4x and 3x make 7x.
I bet you make it look easy, but when we're gonna do it,
Yeah.
I think we're gonna have some trouble.
Yeah, well, we're going to talk about that in a second. We're going to show you
And you can
Few
only
examples.
use that foil with 2 brackets, whatever.
2 binomials. That means this bracket has 2 terms and this bracket has 2 terms.
If you have 3, you can't.
You
What
have
if there's
3
3
terms.
brackets that have more than 2
No,
brackets?
so you just 2 brackets, 2 binomials. That's the method. Okay?
Could you use long multiplication on that one?
Like I was stacking
Yeah,
what I
you
did.
stack it.
Yeah, sure.
What? Where?
Okay. So, FOIL. First in each bracket. What is the first in each bracket? X and x. So x times x is x squared. The outside in each bracket. X and 2. What's x times 2? The inside in each bracket. Negative 3 and x. And what does that make? Negative 3x.
Minus 6.
And the last in each bracket is minus 3 times 2, which is
Negative 6.
negative 6. First, outside, inside, last. X squared minus x minus 6. Okay? Plus 2 subtract 3 is negative 1x. Okay? All right, let's try another one.
Is this your preferred way?
It will be yours by the end of it. It will be, because you'll find, the reason I say that is because the next section that we have to do, right now we're multiplying polynomials. The next section is dividing, or what we call factoring, which is working from this back to that. So you'll understand why. Hey, no commentary needed.
Use the opposite formula.
Okay, first in the brackets are what?
Squared.
X and X. X squared. Outside. Minus 3X. Inside. 4X. Last.
Negative 12.
Negative 12. X squared plus X minus 12.
We can just put 1, we don't have to put, or like 1x, you don't have to put the 1 in front of the x.
I don't have to because it's assumed. But yes, if you like it better that you put the 1, then that's okay too. Yeah, that's all right. 4 subtract 3 is 1. You put 1x, that's okay. We understanding what we're doing here?
Yep.
Okay. Okay. First, what's the first in each bracket? 2x and x, right? 2x squared. Nothing changes. The outside, 2x and 1. So when I multiply them, 2x. 2x times 1. Okay, the inside,
Negative 3x.
negative 3x. The last, negative 3 times 1, which is negative 3. Collect your like terms. 2x subtract 3x. Minus x, minus 1x, minus 3. Okay? When I multiply a binomial by a binomial, I usually end up with a trinomial. Because the terms collect are like in the middle there. There is, sometimes there isn't, but for you guys, it should almost always be that way. We okay? All right. Do this on your own then. Use the FOIL method. Put it down on paper. Write it down. Put it at the bottom of the page, wherever you got to put it. Write down what your answer is. Or maybe you think you have it already. Okay? All right. First,
X is
which is x squared. Outside, 5x. Inside, last, how many of us got it right? Okay? Almost everybody. It's pretty good. It still seem easy, Grace? Even though I'm not doing it?
Yeah.
It's okay? I think this is your easiest method to do this, guys. And what it does, like I said, is we tomorrow or the next day have to work from here back. So it's important that we know how to get to this first. How to do that. Okay? One more here. Gonna increase the difficulty a little bit here. And see how we do. So most times you'll end up with a trinomial, and then one question later I show you one that doesn't end up being a trinomial.
It's a Y. That was a 4. If it was one, if that was a 4, it's gonna have
Okay. 2x times 3x, that's the first, we agree?
Yeah.
What's 2x times 3x?
6x squared.
6x squared, very good. The outside is 2x times 1, 2x. The inside is y times 3x. Nice, nice. 3x, y. And then the last is y times 1, which is 1y, and that's your solution. Awesome. You can leave it like that. There's no common anything there, so you can't simplify it. That's what it is. Okay? How many of us got that right? Okay, so that's not bad. Still some.
Get the outside wrong.
The outside is this and this.
the 4 was a Y.
And the inside is more.
The inside is this and this. So you look at it like this, all right? Here's your, if this was all in one bracket, let's say, the outside of the bracket would be these two numbers. The inside would be these two numbers. Okay, so that's a good question. Okay, anybody else have questions? Yeah, Kylie.
What if the y is in front of the x?
You don't put the y in front of you. It wouldn't be wrong because you're still multiplying and it's not wrong. But when you write out any values, variables, you always write them in alphabetical order.
Okay.
That's a rule of thumb. Okay? Any other questions right now? Are we okay? So that basically will take you all the way through. If you skip number 1, that'll take you all the way down to number 6. Number 6 is where you get into where you might want to use your stacking method today. But for the first part, don't do 2 without algebra tiles. And like I said, if there's people that want algebra tiles, I can get you algebra tiles. But for right now, I prefer not to use them. Okay? You need to, no music today, no partners today. You need to work hard on this and get the basic understanding. Because we spend so much time on this in grade 11 and 12. You got to be able to do it. Yes, Maureen.
Where it has like the multiplier.
Stacking one? Sure. This guy right here?
Yeah.
Okay, why don't I do this? I'll do a page so you've got both methods of that. Okay? Alright. Get to work. Yeah. He's going. That means I get 2 more that can go, and then after that, nobody's going. What's up? Okay, I mean, shut the camera off and then.
Could you flip back to the other one later?
Yeah.
The one that you just